Hello, welcome back to the shop. Today we're going to make a start on how we are going to do the repairs that we talked about in our last video on the planer. I'm standing next to the metalworking planer now. We're going to put a spot face on the tool head, and we're going to, where the nut goes to lock it, and we're also going to replace the two rods for the belt switching mechanism. Or I'll bring you in closer and we'll have a look and make a start. Alright, here's our tool head on the planer. You can see that, you've seen that many times before. We're going to put a spot face on the screw on the bottom here on the casting. So what we're going to do is we're going to lift the slide up, sort of draw the screw out, and then we'll have to take the swivel plate off here, which allows us to cant that over to whatever angle we want. You'll be able to see the mechanism inside when we do that. So I'm just going to grab the handle here and wind it up. Oh, I'll have to, because I've locked everything up, I'll have to undo the nut at the back. Right. Remember, we had our special spanner that a cheap spanner this was, a 9/16 combination spanner, which I bought just for this particular purpose because I'm going to cut the end of it out. But it works quite well. See, that's withdrawing the slide now. Don't forget, this was, what was it, 3/8 UNC did we say? There you are. You can see the screw now and the nut that I put on for locking down, and we're tying it up on this face here, and this face is curved. Let me just see if I can zoom you in a little bit and you can see perhaps a little bit better. Yeah, see that, that's curved. So we've only got a point contact, which is not good really. What we want is a contact with the full area of the material. Because what would happen in time, we can keep tightening down them two little points, they'll eventually swage out and it'll cause us problems, fouling with the threads and other things. We want a proper spot face on there, proper spot face, and we'll put a washer on as well. And the purpose of the washer is to protect the surface and to distribute the load. So anyway, that's what the tool head looks like. Can you see that? Oh, well, that's not supposed to happen. But anyway, what I'll do is I'll take these two nuts off now. It's 1/2 inch. Made all these studs. I think I told you some time ago in one of the earlier videos that we did. Alright, now that should just come out. And it does. These are the plates that fit behind. I made new ones. These are new ones that I made. There you go. And I made studs for them. The plates that I think the original ones, which were fitted when the machine was built, were obviously of good quality. But over the years, I think the threads stripped in here because they never had studs in. And somebody's made some new ones, and they were in a right state. They were crap. They were bloody awful, they did. So I made some new ones, and they fit in nice. There you go. So there you are, made some new studs. When you're making studs, it's an interesting little project as well. They're not easy to make. And if you can imagine, we've got probably 3/8 of an inch, which is just inside here. And we've got a shoulder there, which is probably about 7/16, and then we've probably got about 3/4 of an inch of thread there. You've got very little to grip. If you're going to screw cut these with a single point tool on the lathe, you've got virtually nothing to grip with, and you need a certain distance to get your tool out, else you're going to crash into the chuck or the collet. So what I did is I made some little special collets for gripping the threads, which allowed me to use my tailstock die holder. And I'm going to bring it out a little bit because we're getting a bit cramped now. Let me just clean my hands off and I'll show you the little collets. I'm covered in oil now after doing that, so let's just zoom out. Oh, you're going the wrong way there. Right, you can see the little bits laid out here. Let me grab them two collets that I made. I made one for 3/8 UNC and one for 5/16 UNC, which is what these are. Alright, these are the two components. Let me see if I can come a bit closer and you can have a better look. I've got to be careful because it doesn't focus too well sometimes. Yeah. And you can see what you do. They drilled and tapped. This one's for 3/8, and then you drill it for clearance in the end, so that when you screw the stud in, you actually screw up on the shank as well, and it helps to locate it. Well, that's the 5/16 one there. And then what that does is you put that in your collet chuck. Yeah, put that in your collet chuck, and it clamps down and grips on the thread then, and it can't move. So you've got something positive to grip with. Because when you're using your tailstock die holder, you need a lot of force sometimes to get the thing to cut, get the die to cut. So there we are. I made a couple of them, and they worked very well. I was quite pleased with them. Did all these with them, and I made some of the studs here for the clamping equipment for on the bed. You know, these are some of them. I've got different sizes. These are 3/8 UNC. I'll just put these collets away. Right. Let's take this over to the bench, give it a clean off, and let's just sort out what we're going to do then. Right, I've decided to do the job on the milling machine. I've put it in here, and let me just take this down and I'll show you exactly what I'm doing. I'm clamping the component. Can you see the boss? It stands up at the back, and also we've got the dovetail that stands up. So what we've got to be careful of is we need to get sufficient area for purchase for clamping between the jaws. And I don't think by clamping on the ring here and on that side there we're going to have enough clamping force. So what I've opted for is to clamp on the outside. It takes all the load off the centre. I'm not going to get any bending moment when we clamp. What I don't want to do is to put any bending moment on this component, because that vice will clamp tight. I don't want to bend it, I don't want to crack it. This is cast iron, there's a good chance it would fracture. I don't want that 125-year-old piece of equipment. So what we're going to do is we're going to clamp it, and all we're going to do is we're going to use our square. I'll just show you. We'll put our square and just sight it by eye, and that'll be quite satisfactory. I'm going to bring you in down here now to the right so you can see what we're doing. Alright, that gives you a much better vantage point, I think. I'm just going to move that to the other side, you can see a bit better as well then. These are just pieces of steel I use for various fixtures. I've got a whole load of them which I've accumulated over the years for various tooling and things like that. I'm just going to pinch that. All the load from the jaws has been transferred through these blocks of steel, through the outside of the casting, through to them blocks of steel, and then to the jaws. And make sure that way it's sitting true. Right. Now, I'm going to take my little square. just going to sight that now. How does that look? How does that look to you? I'll bring you to the front and you can tell me. Right, do you think that'll do? Can you see the little gap? The square? That's all we're doing, just sighting it with a square. If there was any degree of precision required, we would clock one of the faces or something. But we're not too worried about that, not for a spot face. These nuts that you get nowadays, unless they're machined, take it from me, they're not square. The faces aren't square to the axis of the threads. I can tell you some stories about that as well. Just tying that. That looks pretty good. Okay, I'm happy that that edge of the dovetail is square to the vise. It'll be good enough for what we want. What we're going to do is we're just going to flash a cut it straight across. It's not a big heavy cut. It's in cast iron as well. That will machine quite easy this will. So what we'll do, we'll drop the table down and we'll start getting set up for a cutter. Right. Let's put our collet in the ER40 collet chuck. Right. Put the cutter in a minute. Put that in there. I'm going to move this back. In fact, I'm going to move it that way. Just watch yourself. Just move it out of the way. We could put a spot facing tool in here, but I don't think the pilot I've got is suitable for the, if you like, the core diameter of this thread, 3H I'd probably end up having to make a special pilot for it. It's like a pilot stub that fits in, that locates the cam port. And let me just grab the this one. Here it is. What I've put in there is a 12mm 3-flute carbide cutter. I think the angle here, I think it's 70 degrees. Not sure if that's how you designate them as a router cutter. But I've talked about these before in the past. You've got to be really careful with these because these will shift a lot of material and they'll want to chew into your work. If you haven't got a rigid machine, I wouldn't think about using that. Just grabbed my little books here. I had these when I was an apprentice, when I started my apprenticeship. You see them there. Dormer Tap and Die Information Handbook, Dormer Twist Drill and Reamer Information Handbook, Dormer Milling Cutter Information Handbook. Now these books here, the technology is from 40 years ago, over 40 years ago. Carbide was just starting to come in on milling machines then. CNC was starting to take off. We already had NC, numerical control, but CNC was just starting to come in then. And it's interesting what it says in here about the 3-flute cutters. Let me just find the page, what it says in here about them. 3-flute router cutters. There you are. See? 3-flute router cutters. It says 3-flute router cutters are made to the same close tolerances on diameters as slot drills. They are specially designed to meet the needs of NC machining centers, which means numerical control, where the combined functions of the slot drill and the end mill are required without a tool change. They will plunge, feed, mill-size slots and profile mill. They are also frequently used on free cutting materials which produce a voluminous chip formation, where the wide flutes of the router cutter are shown to be advantageous. And then it says here NB, I think that nota bene or something like that, don't know. As with most multi-purpose tools, router cutters are not as efficient as slot drills for producing slots. Also, they do not produce as fine a finish as end mills. So there you go. Don't forget, this is technology 40 years ago, over 40 years ago. Things have come on considerably since then, but I think that's a good guide, shall we say, for the use of them router cutters. And because they're made for high production machines, they will remove material quickly. You just watch one of them CNC machining centers operate. There's no way you could generate the speeds and feeds on a machine like this to accommodate, to give you the maximum performance from a tool like this. You just couldn't react quick enough, you couldn't move it fast enough. But we can certainly use these. We have to tone it down a little bit on speeds and feeds. You've got to be really careful with this. And I didn't, actually a bit of information for you as well, I didn't believe there was a lock on the x-axis on this machine. Certainly from the point of view of being a horizontal mill, you'd say, why would you want a feed on the x-axis? Because that's the direction you're always feeding on a horizontal mill, because your arbor goes through that way. Yeah. But I always wondered if there was there's no stop whatsoever. And what I was doing, let me just show you around the corner here. You can just see my hand in the corner of the picture there. So let me just bring you over and I'll show you. Right, this is the automatic feed unit on the end of my milling machine. It is a universal mill. And you can see, I don't know if you can see here, let me bring you in a little bit closer, you're a bit too far away. Right, now let me just pivot you a little bit. I don't know if you can see everything you need to there. Alright, there's two positions this lever can be in here. That is hand wheel mode here, so it's manual. You've got to go to the other side and operate the handle to traverse it. That means that the automatic feed gearbox is disengaged. There is automatic feed, so in other words there's a little motor drawn there. Push that across and it's in automatic feed, and I can start it off that little control panel. And if we were to try and turn the handle now, it won't turn. Let me demonstrate that. Right, there you are, it's locked up. And I thought that that was how you actually locked the x-axis, just by putting the machine into automatic feed. Obviously not feeding the spindle here. If I operate this now, I've got the power off, haven't I? But yeah, I've disconnected, you see in the corner. Let's put that in. There you go, the power's on now. If you just watch the handle, can you see the handle there? Wrong one. There you go. Can you see it turning now? The automatic feed's on, so that little gearbox is working now. Stop. To the way. There you go. So I thought there was sufficient resistance within the drive to actually lock that, but that was crap. I was giving you some bum steer there. Because when I was doing the machining on some components a week or two back, I was getting a lot of resonance with this cutter here. And for those of you who don't know what resonance is, when your machines are working, you've got a natural frequency on the machine, and if you're doing something in operation that generates a frequency, exactly the same frequency as the machine itself, you get resonance and it will shake your machine to pieces. For example, if you've got your car running on the road it's running along there, it's got a natural frequency to it. Something happens to a tyre for whatever reason, maybe a nail goes in it or something like that, you change the frequency of the tyre, and if the tyre matches the frequency then of the car, the thing will shake itself to pieces. You know, a wheel bearing starts to go, the frequency changes and the machine destroys itself. So with these cutters, you've got to be really careful with them. Be extremely careful. Now, you can just see there, I'm going to see if I can zoom you in, zoom you out, zoom you in. I don't know if you can see if it's clear enough to you, but just there is the table lock for the X-axis. I was looking over it the other day and I thought there must be a table lock for the X-axis. I thought, oh, what's this here, this nut? And I put my spanner on it and it locked up. I thought, wow, hidden in plain sight. So there we are. I was giving you some bum steer. There is a proper lock on it. You don't need to mess around with that. You can see the lever, I've just put it back into hand wheel. It was there. It's back into hand wheel mode now. The lock is there. That's it there underneath. It's a little nut. There's no other locks. I haven't seen any others. I did check all the way around. There was nothing else. So there's that there. And it'll be interesting to see how that functions when we start doing some more milling work. This will be very simple and straightforward, but we'll have to be careful because we've got it sticking up a little bit here. But anyway, let me bring you in a little bit closer again, back where you were, and you can see what's going on. This is time now. I've just moved the handle out the way. In fact, that's shifty. I don't want to clash with this here. This isn't the proper handle. I made this myself. And I turned a piece of bar here, bored it out, and then I cut the square, the general shape of the square, with my slotting attachment for the lathe, and then I finished it by hand with my files, and then I made a handle and I welded it together. Does the job quite nicely. Right, let me bring you back round where you were and we'll get cracking with this. Right, make sure you've got your glasses on and got your ear muffs on as well, because this is noisy. Right, we're in low gear at the moment. I'm going to bring it. That's in low gear, that's in high range. There you go. Before we do that, I need to be where you are now, so I'm just going to move you out the way. Alright, I've moved you to the other side now so you can see what I'm doing here. So I need to be here where the wheel is, you see, which is where you were standing. We'll just bring this over. All we're going to do is just enough to clean that face up there so we've got a nice flat turf face. We're not doing anything spectacular. Just see where it was in relation to the work. Right, there we are. Just going to get a nut and a washer just to check how much that how much we've taken off there. We haven't taken much. It looks like it might be just enough. Right, let me grab a nut. It's 3/8 UNC, we said. Pretty sure it's that one. 3/8 is the same washer as see, we got a 3/8 nut, and a 10mm washer is pretty much the right size for a 3/8 bolt or thread. So I put that on there now. We've still got a little bit to take off. We're not quite full diameter. Not a problem, we'll take a little bit more. It's better to have material that needs to be taken off rather than take too much off. As Keith Fenner says, it's always better to be looking at it than looking for it. Alright, let's go. We'll put a bit more of a cut on as well. In fact, let me switch the DRO on. I've been talking with you that much, I haven't even switched that on. There you go. It's on now. I'm going to put a little bit on, so if that's at 52, we'll go up to about 70, that'll do. Just have a look. Alright, I think that'll do. I'll let you have a look at this here. Right, you can see the little flat that we've machined on there. That's the flat washer. Fits on there nice. And the nut will sit on there. So that's it, job done. What we need to do is to deburr the edges. I'll clean the thread up with a tap, and that's ready for reassemble. Right, we're back in the metal planer now. We're going to fit this into here. I've put the 2 clamp plates in with the studs. I'm going to give that a bit of oil. There we go. Right, that's the top. There you go. Yeah. See. Right. There we go. Shows degrees on the side, but I can't see one of the fiducial lines, I think it's called. There's nothing marked on the side. I think at some point in time we're going to have to scribe. Well, I know you've got a very fine milling cutter, or one of them engraving tools. Put this in the milling machine and we can centre it and we can put a line on. But anyway, it's a job for the future. Right, we'll set that so it looks right. We can put this back in. Right, I've already got a nut on there, I'll leave that one on. I'll wash it. And that just about goes on, there's just enough clearance for that. So that's okay. Just put any oil in that. Bit extra won't harm. Bit on the bearing at the top. There you go. So come through now. Right. There you go. There we are. Get it all the way through the tool. Slide V-slots. There we are. That's good enough. And all we'll do, we'll just sight that level by eye. If we need to clock it up for whatever reason, we will do. But at least we've sorted that spot face out. That's not looking too bad there. We'll just pencil up there and I'll do, I think that's moved. Got it. Now let's just check, see if it works okay. There you go. It's quite solid. Alright, let's put this back together. There you go. That's it. So that's that job completed. It's done with now. Now we're on the second job now. Right. We'll put these away.